This is every worst military helicopter ever designed. Attack platforms, transports, scouts, naval prototypes, experimental concepts. Some underpowered, some unstable, some catastrophically flawed. First up, early experimental helicopters. Hiller YH-32 Hornet. This early pulse-jet-powered helicopter used ramjets mounted at the rotor tips. It eliminated the need for a tail rotor, but produced extreme noise and vibration. Limited range and fuel inefficiency prevented it from advancing beyond testing. Now this is the Fairey Rotodyne. Designed as a compound gyrodyne transport, it used tip-mounted jet burners for vertical lift and turboprops for forward flight. While technically innovative, excessive noise and rising costs led to cancellation before military adoption. Kamov Kar-22 Vintokryl. This hybrid rotorcraft combined large rotors with fixed wings and turboprop engines. Intended for high-speed transport, it suffered multiple fatal crashes caused by complex control interactions. The program was terminated after repeated instability incidents. Up next, the Piasecki YH-16 transporter. Developed as a heavy tandem rotor helicopter, it was among the largest of its time. During testing, structural weaknesses caused catastrophic rotor failure. The accident ended the program and halted further production plans. Next up, underpowered combat helicopters. Bell AH-1G Cobra. Designed as a dedicated attack platform, early variants were equipped with limited engine power relative to weight. In high-temperature environments, performance margins narrowed significantly, reducing payload flexibility and limiting maneuver capability under combat conditions. Now this is the Mi-24A Hind. This initial production version combined troop transport capability with attack functions. The added cabin weight reduced agility and climb performance. Its early tail rotor configuration also created handling limitations before later refinements improved stability. Up next, the Agusta A129 Mangusta. Intended as a lightweight European attack helicopter, early variants used engines that restricted lift capacity in hot and high conditions. Limited payload options reduced battlefield versatility until upgraded powerplants were introduced in later versions. HAL Light Combat Helicopter. Developed for high-altitude combat operations, early production models faced power constraints when carrying full weapons loads. Engine output margins required operational compromises, particularly in extreme environmental conditions, before incremental upgrades were implemented. Continuing with overweight and overcomplicated designs. Sikorsky CH-37 Mojave. This heavy-lift helicopter used piston engines mounted in large external nacelles. While capable of transporting significant loads, the complex transmission system and maintenance-intensive powerplants limited reliability. Its size and mechanical demands restricted operational efficiency. Now this is the Mi-12. Designed as the largest helicopter ever built, it used twin rotors mounted on massive wing-like structures. Though capable of lifting extraordinary payloads, structural complexity and logistical impracticality prevented large-scale deployment beyond limited prototypes. Up next, the Kaman K225, an early intermeshing rotor helicopter developed to explore syncropter technology. Its intricate gearbox and transmission systems required constant adjustment. Mechanical complexity and limited performance margins restricted its operational potential beyond experimental evaluation. Hughes XH-17 Flying Crane. Built as an experimental heavy-lift platform, it used tip-jet propulsion on an enormous rotor system. Fuel consumption was extremely high, and the aircraft required ground support equipment for engine start. Operational practicality proved unsustainable. Now, poorly armed and vulnerable platforms. Bell OH-58D Kiowa Warrior. Originally designed as a light observation helicopter, early armed variants carried limited defensive systems. Thin armor protection and modest weapons capacity restricted survivability in high-threat environments before later upgrades improved protection and targeting systems. Now this is the Westland Scout AH-1. Developed as a light utility and reconnaissance helicopter, it was later adapted for anti-armor roles. Minimal armor and exposed components increased vulnerability to ground fire. Its limited speed and payload-constrained tactical flexibility. Up next, the SUD Aviation Alouette 3. Primarily built as a utility helicopter, some versions were fitted with light weapons for close support. Limited protection, restricted armament capacity, and modest engine output reduced combat resilience against modern air defense systems. Mi-2 ERP. This light-armed version of the Mi-2 utility helicopter carried anti-tank missiles on external pylons. Its small airframe and limited armor offered minimal protection. Performance margins narrowed significantly when operating with full weapons loads. Continuing with rushed wartime conversions, Sikorsky H-34 Choctaw. Originally built as a transport helicopter, several units were rapidly adapted for armed escort roles. Added weapons increased weight and drag, reducing lift margins. Limited armor protection and improvised mounts constrained sustained combat effectiveness. Now this is the Mi-4AV. Developed from a piston-powered transport platform, this variant was equipped with anti-tank missiles and gun pods. The additional armament strained performance limits. Aging engine technology and limited defensive systems reduced survivability in contested environments. Up next, the UH-1B Huey. Designed as a utility helicopter, early gunship configurations were implemented before dedicated attack models existed. Added weapon systems reduced speed and climb performance. Protection levels remained minimal during the earliest phases of armed deployment. Next up, logistical and reliability disasters. Kaman H Huskie. Designed primarily for firefighting and rescue operations on military bases, it used intermeshing rotors powered by a turbine engine. Maintenance demands were high, and limited range restricted deployment flexibility. Operational roles remained narrow and highly specialized. Now this is the Mi-10. Developed as a flying crane variant of the Mi-6, it featured extended landing gear for external cargo transport. Complex loading procedures and limited operational versatility reduced widespread adoption. Its specialized mission profile constrained broader logistical usefulness. Up next, the Boeing Vertol CH-46C Knight. Introduced as a tandem rotor transport helicopter, early deployments exposed reliability concerns in transmission components. Maintenance intensity increased under sustained operations. Performance limitations in hot climates affected lift capability before later structural improvements were implemented. Finally, cancelled programs and strategic failures. Lockheed AH-56 Cheyenne. Developed as a high-speed attack helicopter with a compound rotor and pusher propeller, it promised advanced firepower and performance. Technical difficulties, vibration issues, and shifting military priorities led to cancellation before operational deployment. Now this is the Ra-66 Comanche. Designed as a stealth reconnaissance and attack helicopter, it incorporated advanced avionics and reduced radar signature shaping. Escalating development costs and evolving battlefield doctrine resulted in program termination after limited prototype production. Up next, the Boeing Sikorsky Ra-66 successor concepts. Proposed as next-generation armed reconnaissance platforms, these follow-on designs emphasized modular systems and advanced sensors. Budget constraints and shifting procurement strategies prevented transition beyond conceptual or early demonstrator phases.